Okay, so the question we are going to tackle today is valid anagram. So given two string s and t, we have to return true if t and s are a valid anagram and false if they are not. Just a quick uh, definition of anagram. Basically, they are words who uses exactly same characters. They can be rearranged, but the number of characters and the value of the character should be same. For example, you can see here we are using 2, 3a, 3 A's. So in the second one, we should be using 3 A's as well, although the order doesn't matter. So you basically want to return true for this case because every other character will match to every other character here in numbers and value, not in position. For this one, you can see we have R, A, and T. So T is not used anywhere here. That's why this is not a valid anagram. Okay, so to solve this solution, one easy way would be to just sort both this array and then compare. So if you do that, you'll get a valid result, but the issue with that is the time complexity will be n log n because we'll be sorting a string. So we don't want to do that. We want to try to solve this in a linear time if possible. If you look at the constraint here, you can see both the variable have lowercase English letter only. That means we can utilize these particular constraint. So if you think about lowercase English letter, there can be only 26 letters, which is a very small number. So we can use that to track the values. So what I am planning is potentially what we want to do is we want to just track the number of uh, times a particular character has occurred in the first variable, and just we need to make sure that the same character has occurred in the second variable the same number of time. Okay, so to do that, what we are going to do is we are going to create an array, and we are just gonna say that array is called array s. Okay, s stands for variable s, and this will be of length 26. So if I do this, basically if I just print, you will see we'll get, I think, an array of 26 zeros. Yeah, so you can see we'll get something like this. Okay, and the reason we are doing this is we want to update these values as I progress through this. Okay, and then similarly we are gonna create another variable. We're gonna call this array of t. Okay, now what we are going to do is we are gonna go through both of these array, and for every element we are gonna update that particular element position in these array by 1. So for example, let's just take this one, s. So for the very first element is a, right? So in this array a should be at 0 position because from a to z we are matching 0 to 26. So a will go at the 0th position. So what we'll do is we'll increase this value to 1. Then similarly n will go to its corresponding position here, and we'll update that value to 1 or plus 1. And then again a, so this a will become 2. So I can just try to do that and show you what we'll be printing here. But the basic logic is we create like a list of 26 numbers for both of these um, variables, and that list should match. If those list exactly matches to one another, that means the number of characters and the type of character in both the variables are same and they are valid anagrams. So what we'll do is for value in s, array of s. Okay, let's also create index. So index will be ordinance of value minus ordinance of A. Okay, this will give 0, and then we'll say index plus equals to 1. Okay, and we do the similar thing for T. Okay, now if we print array of S, print array of T, we should get something like this. Okay, so if we look at this example here, you can see A, for A it says A has occurred 3 times. So A has occurred 3 times, that is correct. Now similarly A, B, C, D, E, F, G has occurred 1 time. So G has occurred 1 time. And if you just look through these values, you'll see that it actually makes sense. All of these values should be updating exactly the number of times to that of what actually these elements have those characters for. And then at this point what we can do is we can just do return array of S equals to array of T. Okay, yeah, so this should work. Now if we think about time and space complexity, basically we are creating 2 arrays which has size of 26 characters, so 20 big of 26 plus 26, and other than this we are not really doing much. So it's like big of k, which is a constant space complexity. For time complexity is big of n, where n is the length of both of these characters. Another length of both of these variables. Another edge case that we might have missed here is if length of S is not equals to length of T, that means they cannot be a valid anagram. So in this case we just return false. I think this should save more time for the use case where we have this case. Yeah, probably save a little bit more time, but yeah. So if this is not the case, basically they'll be of same size and it should be big of n because we're just iterating through them once. So yeah, let me know what you think. Thank you.